So today we will, it's a joint presentation. I have Sunjay-Kumar, who will talk on behalf of Deutsche Bank about the solution that Deutsche Bank built using TimeBase. Business objective, all of the kind of challenges of the solution, how trade surveillance was put together, how TimeBase was applied, the reasons for using TimeBase, outcomes, etc. And then I'll go into like a little bit of technical detail on the subject, and then we'll do a little demo, if time allows, of simulating a particular use case for trade surveillance, which is trade spoofing. We'll talk about that and show how that was done. So with that, I'll pass the mic to Sanjay.
Thanks. I think I'm already hooked up. So very good morning, everyone, and thanks for attending this session. I'm here to share some successes which we have made with EPAM by implementing time-based solution. So before I bore you with a lot of technicalities, maybe I would start with how we started our journey in the bank. Following 2008 crisis, if you think how things have evolved, in last 8 years, 9 years, there has been a lot of regulatory scrutiny and focus. So the way we started looking at the problem in 3 pillars, so we took an objective of how we can have a very comprehensive strategy for trade surveillance and communication surveillance to build a program which can be sustainable. And a lot of focus were roaming around 3 core pillars. So data was one of the biggest core pillars where we wanted to understand what data you need to conduct the trade surveillance and various other surveillance types. Then we also wanted to build the analytics around it, like how you can generate signals to identify the bad financial behavior done by the traders and focus on identifying market misconduct. And the third pillar, which was very close to my heart, was, which a lot of firms always ignore, is the end user experience. We think that we as a technologist have built a solution and given to the end user and they should be just happy with it. So we took a slightly different approach in terms of user experience-based approach, where we have seen like, if a particular trade surveillance analyst is working on a particular alert, what sort of data points it's going through, how much difficult for that analyst is to analyze the vast amount of data, and what sort of technology we should bring in to actually solve that kind of problem. So end user experience and the responsiveness with the data and the analyst was very heart and center of all the design. So as you can see, the overall background was the trade surveillance core objective is to identify the market misconduct. And while doing so, when we use the rule-based detection engine, we generate alerts, and those alerts are getting worked through by the human analyst through a research and investigation workflow. So what I mean by research and investigation workflow is like, imagine like you generated some alert, but we are also equipping the analyst with a lot of data set which he or she can look at to analyze what exactly going on here, like how I know like there is a market misconduct. So one explicit technical challenge we had was as the scope and the product class and the volume of data started growing, the incumbent caching solution what we had in the bank, which was supporting the end user application for investigation to analyst, it started having performance issues. So the key challenges were it's not able to do the on-the-fly mathematical calculation, which means you need to pre-calculate everything and keep it in the memory. Memory footprint started growing. And that has degraded the overall end user performance in terms of sometime one of the guy can take 2 hours to review a very complex fixed income currencies alert, let's say. Yeah? And they need to consume a lot of market data and various other kind of RFQs, trade and order data to understand what's exactly going on. So that was our typical challenge with the incumbent technologies. As a next step, and I'm a big fan of open source, I can openly say that, because part and parcel of our strategy was like, rather than having a strategy which is totally supported by independent out-of-the-box vendor product, we created those three pillars: data analytics and end-user experience. And he started looking at open source, like how open source can help us solve some of those problems where a lot of people like us, financial industry and our vendor partners, are contributing heavily in FINOS to build these solutions. And I encountered TimeBase as one of the option. Rather than directly picking TimeBase, we have done an extensive 3 to 4 months of proof of concept with other competitors in the market. And we found that TimeBase have been successfully satisfying all our criteria to support our investigation workflow in terms of responsiveness. And that resulted into, if you highlight some of the key feature is, low latency was one of the feature which I highlighted. Like when you are dealing with the large corpus of market data, and when you are trying to identify what's going on, then zoom in, zoom out is going to take a lot of time. And that where TimeBase has really supported with the nanosecond response, and the users were happy. So wherever they were pretty much able to take like 1 hour, 2 hour investigating in some complex topic, now they got this nugget of information on tip of their fingers. Yeah? And that really helped to see the solution. If I talk about some of the core outcome, obviously the open source solution and the great support from EPAM has been crucial for our implementation, because open source just provide you a single tenant kind of installation, and we wanted to build a robust solution, multi-tenant and fully resilient. So we worked with EPAM to implement TimeBase in our firm to address this problem. And in terms of our alert efficiency review, the topic which I was talking about, where analyst needs to deal with a lot of data, has significantly improved by roughly 30 to 40% pretty much. And once that problem was solved, at least they can invest more time in actual market abuse investigation use cases, rather than spending monotonous effort on just doing the normal false positive alert, which may not be an issue. So that is speed and experience has really made a big paradigm shift for our analyst to look at the problem statement and see how that can solve the problem. With that note, we'll be having some time for question and answer as well, but I'll transfer to Michael to cover some of the technical details and what these guys are doing on with TimeBase as well, and hopefully we'll have some demo as well.
Yes,
Yeah?
thanks, Sanjay. Thank you. The high-level architecture, but okay. And this is the schematic, okay. So yeah, I'm here to kind of dive deeper into TimeBase Community Edition. We at EPAM strongly believe in open source. EPAM is a huge contributor to open source community, not just FINOS, but others. TimeBase is the project that has been around for a long time. It's really battle tested. It's used in many, within many hedge funds. It's used within the industry quite a bit. And in 21, we decided to open source it, contributed it to FINOS. And we're continuing to invest into the open source community edition. We added open source connectors, and then we also published TimeBase Community Edition into Amazon, so you can deploy TimeBase seamlessly in the Amazon infrastructure. The open source connectors, I'll talk about it a little bit later. If there's one thing that I want you guys to walk away with, is that TimeBase is a great fit for trade surveillance, for market surveillance function. And I'll go into the reasons why, but that's kind of the main slide. So Sanjay talked about latency, which is extremely important to make sure that there is performance, that you properly store all of the timestamps of the events. TimeBase can handle very large volumes of incoming data, which is really important in the critical market conditions when there is market spikes. One additional important feature for trade surveillance is ability to combine streams of data, because you have to capture market data, you have to capture order book, you have to capture quite a bit of different streams that will help you with your investigation, and then you need to properly time slice it in a single stream. So that's one of the important features of TimeBase's multiplexing. And we also enable you to store complex message types, so you can make your investigation easier by combining all of the cancellations, all of the market activity under a single trade tree, if you will. So that you can then it really simplifies your analysis, post analysis. These are just some of the metrics that we're proud of for TimeBase. They really talk about latency. So these are microseconds on average. Latency that we've observed is 49 microseconds, and on the outside, it does spike. But if you look at the the percentages, it comes to about 1 second per day where you can have an outsized event. So for the most part, it's working really well. There are different mechanisms for getting the message. There is a guaranteed delivery with PubSub, and then there is multicast delivery, where you kind of want to where you can basically throttle the messages, and you can drop some of the messages. Once you've collected your data into TimeBase, you basically then end up doing post analytic. You're doing post trade capture analytics, and TimeBase, again, has a lot of different ways for you to do it. There is a built-in QQL language, which works sort of like a SQL query language, where you can investigate different time periods, as well as you can integrate. We have integration into Java, C#, Python, Jupyter Notebook, integration with Grafana as well, if you're looking at the logs. And TimeBase can also serve as a messaging middleware, where you can, kind of have one solution for all of your needs, where you don't need to use Kafka or other technologies. This is just an example of QQL. Now we're going to follow up with a demo, so you guys can look a little bit more into how TimeBase works. We prepared a demo that my colleague will present, where we are basically simulating the trade spoofing event, which is this is when trade spoofing is when a trader tries to influence market by creating fake orders and then quickly canceling these orders. So you basically create a large order to simulate activity that will help you, use the market in your advantage. This is just an example of the Python API. And, sorry. And this is also really important to mention, that it's very easy to get started with TimeBase. We have all of the instructions. We have a lot of open documentation of how you can download TimeBase, install it on your laptop, You can connect it to the open source for, to get market data. We have connectors to cryptocurrency exchanges, and you don't need to pay for that. So you can actually get real kind of order book, and you can get real trading data to build your analysis, or just to play with TimeBase to see what it does, how quickly it works, etc. And then we have a full path to scaling it as well, of course, as EPAM is ready, as we did with Deutsche Bank, to fully support the development efforts or fully support production deployment efforts as well. So that's I think is very important to also keep in mind that we have good support for TimeBase. And these are just some of the URLs. I think the presentation will be available to you. And this is where you can go and get the code. You can get all of the documentation, API documentation. And like I said, it's extremely easy to install and use. OK, with that, I guess we'll do a little demo, right?
And then we'll open for questions.
And then we do the questions. So we have like 5 minutes. OK. Do you want to? This is Valery, my colleague.
Yes. Yeah. Thank you, Misha. Hi, everyone. OK. So all right. So my sample will be about layering spoofing algorithm, which we see now. It's trading. So just to give you the background. So this is like spoofer behavior. The trader tries to submit free orders to buy in order to influence the market, showing the high demand on the buy side, and then in a certain window, in a few seconds, he or she cancels the order, and the real attention was to sell, right? So we move market a little bit, and then basically execute our order, right? So each 20 seconds, as we speak, this trading bot simulates the behavior, right, on a simulated prices. Okay, so let me then show you how the actual prices works. If you go to my another application, let me move it to the second screen. Okay, so this is basically the TimeBase background, right? So we see the real-time playback of the market depth data, level 2. It's a simulated data, so we have here the spike at the end of the day. So it's futures with market depth stored in TimeBase, and it's being playbacked from the past. So one of the key features of TimeBase is to provide you with the means to simulate your algorithms, your analytics against historical data, and make it seamless. So this is the level 2 data market depth. We basically support also level 1 data, level 3, all market orders, and everything, right? So the data is coming into TimeBase, and it's stored there. The orders that the trading bot simulates on the ground also goes to TimeBase, and they're stored there, right? And what we are going to do now, we're going to analyze the data using the TimeBase API. Okay, so here's my Jupyter notebook. I'm going to query the data from TimeBase using basically the simple query here, which will give me all events from what we call here Amber events, which is the trading history, right? So TimeBase stores not only the market data, but also the actual data warehouse stored in the form of fixed inspired messages with the order submission. Fix, I mean the Financial Information Exchange Protocol, also part of FINOS, by the way. We store trading history here, and with this request, the aim was to collect the trading history and let me run it right in front of you, right? So we get basically the trades from this spoofer trader who submits orders, and we see partial fills, cancellations, and submission events, all events, right? So we simplified a bit the hierarchy of messages, and TimeBase stores hierarchy of messages in polymorphic streams. So basically three important, like TimeBase is 3-in-1, let me remind you. The message broker that allows you to connect different components in one place. It also data modeling tool where you can store your model in comparison to other tools like Kafka or other Timebases. And the third is to do the historical storage, right? So the actual, yeah, please. Well, increase the font size. Okay, let me do that. Right, so here we have the actual trading history, right? The next step will be to basically write simple code. Like, again, I'm not going to pretend that I'm trade surveillance specialist here. We are writing this simple code to detect actual cases when in the close horizon of the time we have subsequent orders that were submitted on one side of the order book, and then they were canceled, and the subsequent actual trade on the opposite side was sent. Okay, so we have here the function basically that uses the the data from the trading history, and we detect basically all these situations. Right, when I run this spoofing detection behavior, we see that okay, each 20 seconds as we speak and as we see, okay, each 20 seconds, the spoofing behavior was detected, and like as we saw, 3 subsequent orders were submitted. Cancel ratio here is 1. So potentially, like in the real world, spoofers are not that much naive. They will send like a random number of orders with the approximate with the distributed volume. They may also pretend that some of the orders are intentional orders, not all of them are cancelled, to make this spoofing detection not so obvious. So this is basically the detection of the spoofing cases that we see as we go, right? What is important also, hey, Mike, whatever.
No, we just said I needed time for questions.
All right, sure. Yeah, and I would like to improve a little bit this case because one of the key features of TimeBase was multiplexing, as Mike mentioned. So we are going to take into account also the market prices. And here is the case where I'm getting the prices from TimeBase. And with this simple query, I'm going to simplify the market depth on fly into the form of level 1 messages, best bid offer and trade messages. So just top of the book, the best bid and best offer, and actual trades. I'm collecting this using the query from TimeBase, then basically reconstructing my model into simple trade and best bid offer messages. And with this query, I'm going to take all these trades into account. Yeah, so this is basically the market data, 500,000 messages, so 300,000. And then the improved spoofer detection will basically handle all these prices and output the subset of, or as it's called here, filtered spoofing behavior, where we take into account the actual price move, or as it's called here, price jump, that happened right after the placing the orders, because in general cases, we can submit orders and they will not have any market impact. So here we see, and we want to filter only those cases where the market impact actually happened. So we multiplex trading history together with the market depth information. And as a result, we have the less number of spoofing cases. So basically, here is the statistic. We removed a number of false positive cases from the first example. So that's the way how you can basically combine. Yeah, so in the first algorithm, we have 205 alerts, and with the improved, we basically have 10-15% of that amount. So that's illustration of how TimeBase can serve the needs of trade surveillance. Thank you. Yeah.
So if there are any questions, I can.
thought that was absolutely fascinating, and I was delighted to be chivied in by this chap to do the Deutsche one. I saw at the very beginning that you use this based on rules, business logic, which are absolutely for speed and transparency and latency is the way to go. Have you considered, and are you looking at maybe more of a Gen AI solution backing up the business logic?
I can answer that. So the way we are looking at Gen AI is to collect different information. So for example, if you are reviewing a trade surveillance alert, you may like to see what's going on in the Bloomberg chat when traders were talking to the customer, etc. So one of the Gen AI uses we are thinking about is take all the unstructured data set around a particular alert and try to summarize all of that information as more like a pitch book for that analyst to review and digest. So you as an analyst don't need to manually go and different part of the application and try to understand. All of that can be summarized, and then you can make a still human on the loop, make the conscious decision what action you have to take. But for the detection, I think we are still pursuing more around, because it's a structured data problem, more around machine learning, conventional machine learning models and mathematical models as compared to using Gen AI. Gen AI is more for the end user convenience, how I have structured and unstructured data, how I can combine, summarize, and more or less create a closer note of the alert for the analyst. And then you can see, makes sense, I can see that happening, and then you can take an appropriate action.
It will be interesting to see the latency for the Gen AI solution, because sometimes that can take a bit longer than a nanosecond.
Obviously, Gen AI solution obviously is not nanosecond. This one is more a specific problem where you are playing with the market data, order data, and you are in an investigation screen. You want to zoom out, zoom in, and see the market data, what's exactly happening. You don't need to store all those calculations in your backend architecture. You can just see it and do it with the help of TimeBase on the fly. And that's the key value add in terms of dealing with the large pullback we need to do. So that's where we focused on implementing TimeBase. But as I was articulating, our overall solution landscape is split into 3 core strategies: data analytics and user experience. So we are doing a lot of in-house development as well to promote and solve the different problem different way, I would say.
There's one more question.
You mentioned that TimeBase was collecting data from various sources. Are they all within the same box? Are you using IPC, UDP? How are you collecting the data?
We have email. Okay, so I think there are different ways to collect data. We have connectors to exchanges. We have an open source connector that you can use together with the community edition that will connect to the crypto exchange. So if you want to collect crypto, like real trading data, you can do that. I think for the exchange you still have to pay for the data usage, but we have connectors to the exchanges as well.
I was more asking, do you know what stack's working underneath it? Like messaging frameworks to connect to the...
It's a messaging framework by itself. So there is a rich set of protocols. You can use Java, C#, Python to connect to TimeBase and basically load the data into TimeBase.
But we also support itch and ouch connectors and binary connectors, Java, C++, C#.
The commercial edition, by the way, is connected with about 100 brokers and the banks.
Sorry. Yeah, go ahead. You can probably
So,
speak.
it's been hinted at. So yeah, we're talking about the enterprise edition. What's the difference between the enterprise and the commercial? And did you evaluate, for your case, it seemed like all of those were vendor products like KEB, and I can't remember what the other one was.
Yeah.
Did you evaluate TimeBase community against any other open source?
Not open source, mainly the vendor products. And we have implemented like a multi-cluster approach. That's where we gone for the licensed version.
Yeah, basically the main difference between community edition and enterprise edition is the cluster that we provide enterprise together with support, professional services and support.
Thanks.
So Deutsche Bank are the, I guess, key
We done some benchmarking because we do have a KDB system on the front office, which they use for storing all the market data, exposing the APIs. So for the surveillance function, we are using the API to do all the collection in a big data ecosystem. And the time-based layer is purely serving us as a middleware supporting our research and investigation workflow, where users want to interact and zoom in, zoom out around analyzing the alert, exactly how the market position was against what the trade was booked and how they were trying to spoof or front-run the market.
Okay, and I guess my question is why couldn't these analytics have been done in KDB? I mean, no, TimeBase probably is cheaper, but Deutsche has an existing, I guess, KDB.
It's a time to market aspect as well. Like there is a set of programs going on within front office what they're using KDB for, and we had our immediate regulatory need to fulfill our obligation. So it was more like a conscious decisions split between like why both solution make sense and they might be used in a different purposes. That's how we have come to a conclusion.
Was multiplexing different streams of data part of it?
I think so.
Yeah. So there are certain features that time-based basically excels at. One of them is multiplexing market data with trading data, making sure that it all gets merged into a single stream.
Yeah.
We have time.
How would you recommend people get started? Like you guys got started.
So I think I think the starting is easy. Pretty much, I was looking at with the team over a weekend, and next morning I asked one of my engineers to, can you pick it up and do a small POC? So getting community edition and doing POC was pretty much straightforward. Few days it was up and running. But to do a proper comprehensive POC plugged with all the data set, simulate a real-time scenario, do some benchmarking, that took some time. So I would say like in POC we might have spent like 30 days, 45 days maybe, do proper analysis. And then the EPAM guys has helped us to get the enterprise edition installed, and obviously when we were implementing there were some product support was also needed. But our in-house engineering team was self-sufficient and documentation was good enough to get on cracking with that. So it's not like much of a, like big thanks to these guys that they do support it with the enterprise edition and the implementation, but community edition, documentation and support provided and the information available was good enough.
Thank you.
Thanks guys.